The focus of this video lesson is systematic withdrawal accounts. A systematic withdrawal account is an account in which a person makes one initial deposit and then withdraws money from it at regular intervals. It can be modeled with this formula: P equals W times 1 minus the quantity 1 plus R over N to the power of negative NT all over R over N. Note here, P stands for principal, W, withdrawal amount, R, the interest rate, N, the compounding frequency, and T, the time in years. Let's take a look at how this is used. Example 1. Laura and Rich deposited $100,000 into an account that compounds interest monthly at a rate of 1.08%. Each month, they withdraw $500 from that account. How long will it take them until the account has a balance of $0? So we're going to be using our new formula. P equals W times 1 minus the quantity 1 plus R over N to the power of negative NT all over R over N. All right, so let's identify what information we have. So I'm going to start with the principal. So remember, the principal is the amount of money we deposited. So we can see here that we have deposited $100,000, so we know that that is our principal. We know that we are withdrawing $500, so we can see that here, withdraw 500, so that's our W. We can see that our interest rate is a 1.08%. Remember, when we plug that into the formula, it must go in its decimal form. So a 0.0108, and that will go there and there. Then we have our compounding frequency, and we can see here, compounds, let me use a different color, compounds monthly. So we know our compounding frequency is 12 times a year. So that's our N, which goes here, here, and here. Now note, the only thing we don't have is the time, or how long. And we can see that that's the question we're trying to answer. So we're trying to find T. All right, let's go ahead and plug in all the information we know. Okay, so we have 100,000 is equal to 500 times 1 minus the quantity 1 plus 0.0108 over 12 to the power of negative 12t over 0.0108 over 12. Now the first thing I'm going to do is similar to what we did last time, is I'm going to start with just the simplification of the part in the parentheses and the part in the denominator. Okay, so let's grab our calculator. And let's do the numerator first, the part in the parentheses. So I have 1 plus 0.0108 over 12. And then just make sure you're using a scientific calculator that follows the order of operations. So we know that this part in the parentheses is a 1.0009. Now the denominator is a 0.0009. So we're going to rewrite that. Now the next thing I'd like to do is I'd like to get rid of this fraction here, this divide by 0.0009. So the opposite of dividing by that would be multiply. So I'm going to multiply both sides of the equation by that. In doing so, the ones on the right will cancel, and then on the left we have our 0.009 times our 100,000, which is 90. So I have 90 is equal to 500 times 1 minus 1.0009 to the power of negative 12t. Now I see that I have here this times 500, and I want to get rid of that. So I'm going to divide both sides by 500. Now let's go ahead and calculate 90 divided by 500, and that gives me 1800ths, or 0.18. So this simplifies to 0.18 is equal to 1 minus 1.0009 to the power of negative 12t. Now I want to remove this 1, so I'm going to subtract 1 from both sides. That gives me a negative 0.82 is equal to a negative 1.0009 to the power of negative 12t. Now because both of these are negative, I'm going to multiply, not actually, but just, I'm not going to show it. I'm going to multiply both sides by -1. So times the -1 times -1, and that's going to remove the negatives from both sides of the equation, right, that are in the front. So now I have 0.82 is equal to 1.0009 to the power of -12t. Now remember, at this point, because we have a base and we have our power and our variables in the power, we must use logarithms to remove that power, that variable power. So I'm going to take the log base 10 of both sides, our common logarithm. So log of 0.82 and log of 1.009 to the power of 12t. And it does look like there's a little typo here. This should be -12t. So make sure you fix that as you write your notes. So then that gives us, using the power rule, this will jump out front. So now I have log of 0.82 is equal to -12t times log of 1.0009. Now I want to get the variable t by itself, so I'm going to remove the multiplied by -12 and the multiplied by log of 1.0009. So I'm going to divide both sides. The ones on the right will cancel, and then on the left we're going to calculate. All right, so let's go ahead and let's see what this comes out to be. So I'm going to grab my calculator again. And remember, when we're using the computer calculator, we have to type in the number and then log, divided by, we got 12 negative, hold on, give me a moment. Okay, so 12 negative times 1.009 log. That did not type in correctly, so let's try this one more time. 0.82 log divided by -12. It does not like that. Okay, so I'm struggling with using this calculator, so I'm going to grab, we're going to do Desmos calculator. So let's get in here really quickly, and let's do log of 0.82 divided by -12 times log of 1.009. Now you'll notice that because I was struggling with the signs and just how to type it into the computer calculator, I just moved to a different calculator, and that's totally fine. So we can see that it's about 18.38. So let's jump back over here. So about 18.38, which is about 18.4 years. So we're going to say Laura and Rich will have an account balance of $0 after about 18.4 years. I'm not sure what that is. Let's cross that up. And that's it. All right, your turn to try. Ramin deposited $40,000 into an account that compounds interest at a rate of 0.96% monthly. She has set up a direct withdrawal of $256 every month to pay off her student loan. She has a 15-year loan. Will she have enough money in her account to cover all of the required loan payments? Okay, give this a try. If you would like to get direct feedback, submit your response on on Teams direct message, and then please make sure you submit your final work on Canvas to get credit for the assignment. Really quick recommendation, this can be tricky. Make sure when you are converting the 0.96%, you do remember that in order to convert it to a decimal, you must divide by 100, and then that will give you your decimal form that you need for the formula. Do not put in 0.96 into the formula. That will be a 96% interest rate, which is not what we have here. All right, now it's your turn to get a little more practice. Go to your financial algebra textbook, page 138, complete questions 13, 14, and 15. Submit that for credit.